Students, in this lecture we are going to discuss some properties of matrices, which include addition properties of matrices, multiplication of matrices, scalar multiplication of matrices, as well as transpose of matrices. First we discuss addition properties of matrices. Let A, B, C and 0 are matrices of same order. Here A, B, C are general matrices and 0 will indicate null matrices are zero matrix. Here is written that ABC and 0 are matrices of same order. It means we can add the matrices if they have same order. Same order means they have same number of rows and columns. First property is commutative property. A plus B is equal to B plus A. It does not matter whether we add or write which matrix is first. If we write first matrix A and then write B, then add them, it will be same as first we write the matrix B and then add it to the matrix A. A plus B will equal to B plus A, which is called commutative property. And the second property of addition is A plus B into C is equal to A plus into B plus C. The left hand side shows that first we add A and B, then this resultant, their resultant will be added to the matrix C. This will be equal to either, or if we add B and C and then this add this resultant to the matrix A, both the result left and right side result will be equal. This property is called associative property of matrices. And the third one is A plus 0 is equal to 0 plus A, and this will result A. Here 0 is null matrix or 0 matrix. The null matrix or 0 matrix is such a matrix whose R entries are 0. Every element of the 0 or null matrix will be 0. If we add a matrix A to a null matrix or add null matrix to A, the resultant will be the given matrix or general matrix A, which is stated as our set identity element property. And the fourth one is A plus into minus A. If we add a matrix to its additive inverse, A is minus A is additive inverse of the matrix A. If we add a matrix to its additive inverse, or add, first we write additive inverse of a matrix and add to the matrix, the resultant will be 0 0 mean null matrix. It means if we add a matrix to its additive inverse or add additive inverse to its matrix, the resultant will be null matrix. Additive inverse property is called. And the fifth one is if we add A plus B, if A plus B is equal to A plus C, this implies, this symbol is used for this implies A plus B is equal to A plus C, then this implies B is equal to C, which is called the left cancellation property. And here if B plus A is equal to C plus A, this implies B will be equal to C, which means if we add B into A, this resultant is equal to C plus A, then the matrix B and C will be equal. It is called right cancellation property. And next, second is multiplication of matrices. If we multiply the matrices, what and which property will be hold and which property will not be hold, such as commutative property, associative property, identity, distributive cancellation law, we check them one by one. Here let A, B and C, and here I is the identity matrix. A, B, C and I are matrices such that their product is defined. Then their product is defined mean we can multiply A and B, A and C, B and C, which means all these matrices are applicable, confirmable for multiplication. Then A plus A into B, A multiplied to B is not equal to B into A, such as was explained in addition property. A plus B is equal to B plus A. Here A into B is not equal to B into A. It means commutative law does not hold in multiplication of matrices. generally non-commutative. And the second one is associative, A into B into C. AB into C is equal to A into BC. It means if first we multiply AB and their resultant will be multiplied to C, or first we multiply BC and their resultant will be multiplied to the A, both have the same result, final result will be same, which is called associative property hold here in multiplication of matrices. And third one is, here I is identity matrix. Identity matrix is such a matrix whose diagonal elements are 1 1 and non-diagonal elements are 0. If we multiply a matrix A to identity matrix R, first I and then A, the resultant will be A. Identity element property, which is called, here I is unit matrix or identity matrix. And fourth one property is A into B plus C is equal to AB plus AC. Here left hand side shows that if we add B and C, then multiply this resultant to the A is multiplied to the addition result of these matrices will be equal to, here first we multiply A to B and then A to C, and then we add their resultants AB and AC, both left hand side and right hand side will have the same result. This is called distributive property. And the fifth one property is AB is equal to AC. It does not mean B will be equal to C, like as we discussed in addition cancellation law, which was proved. If A plus B is equal to A plus C, this implies B is equal to C. Here this property is not hold. If AB is equal to AC, it does not imply B will also be equal to C. It means cancellation law is not applicable. And the fifth one property is, if AB is equal to 0, it means if we are multiplying A and B and the resultant matrix is null matrix, 0 matrix, it does not mean A is equal to 0 or B is equal to 0. Both the matrices, if both the matrices are not 0, then also the resultant can be 0 matrix. Product of a true non-zero matrix may not be 0 matrix. And next we discuss scalar multiplication property and transpose property of a matrices. Third one is a scalar multiplication of a matrices. Here let A, B are matrices conformable for addition. It means both have the same order. As well as multiplication, it means both A and B are conformable for addition, as well as for multiplication we can also multiply both of them. Here let K and L both are scalar numbers, then these properties will be hold in matrices, which is first property is KL into A. If both the scalars are multiplied and this is multiplied to the matrix A, or we multiply K and right side is K into L and A, both the results will be same. It means if we first multiply both the scalars and their product, their result is multiplied to the matrix A, and here if we multiplied the first scalar to matrix and then again multiplied K to the matrix, this resultant LA left hand side and right hand side will be same. That means associative property hold. And if K into A plus B is equal to KA plus KB, here it shows if first we add A and B, then their resultant is multiplied to the scalar number K, it will be equal if first we multiply the matrix A with the scalar and B is also multiplied with the same scalar, and after that we add them, this resultant will be same. It means first we add two matrices and then multiply to a scalar, or first we multiply both the matrices by a scalar number and then add them, both the resultants will be same. And next one property is K plus L into A is equal to Ka plus La. It means K and L are if two scalar numbers, first we add them and then multiply to the matrix, the resultant will also be equal. First we multiply this matrix by K scalar number and A also another scalar number and then add them, this will also be equal to left hand side will also be equal to the right hand side. And the fourth property in the matrices is transpose of a matrices. Here T shows transpose of a matrices. Transpose of a matrices is found if we interchange the if we convert the rows into columns or columns into rows. Here if it shows that A transpose of a transpose is equal to A, it means if we take the transpose of a transpose matrix, the resultant will be the given matrix, general matrix A. And the second property is A plus minus B whole raised to power T means transpose is equal to A transpose plus minus B transpose. Here plus minus means if we take plus A plus B transpose, the resultant will be A plus B whole transpose, the resultant will be A transpose plus B transpose. And if we take A minus B whole transpose, the resultant will be A transpose minus B transpose, like as. And third one property is AB whole transpose is equal to B transpose A transpose. It shows that the transpose will be in reverse order. Here is written first and B is written second. In a transpose, B is written first and A is written second. And the fourth one property is Ka whole raised to power T mean transpose will also be equal to K into A transpose. It means if we take multiply a scalar number to a matrices and then transpose, or we take a common K from this matrix and A transpose, it means K if we take common from this, the resultant will also be the same. Or say take common from the matrix scalar number and then take the transpose, the resultant will also be as like as left hand side. And the fifth property is that if we first take the inverse, minus 1 mean inverse of a matrix, multiplicative inverse. If we first take multiplicative inverse of a matrix and then take transpose, the result will also be equal if we take first transpose of a matrix and then take the inverse. Both the answer will be equal. It means it does not affect the final result whether we are taking inverse first or transpose first. And the fifth property is like as property number 3, which shows that if n matrices are multiplied to each other, a1, a2, a3 up to so on an, then we take the transpose, the answer will be in reverse order. We will take transpose of every matrix in reverse order. Here A is written in last, but we will take an in first, and we write all these matrices in reverse order, an, then an minus 1, then an minus n minus 2, and then up to so on a3 transpose, a2 transpose, a1 transpose, like as property number 3. These are some properties which are used in matrices.